all these impellers have exactly the same problem. They definitely cannot mix homogeneously. In pharmaceutical industry, we have a couple of trends, key trends, and some of these trends are driving to the need of homogeneous mixing, absolute uniform mixing. Of course, when you are producing different materials, each dose must contain exactly the same amount of active pharmaceutic ingredient. We have today more and more high potential active pharmaceutic ingredient, HP, APIs. And of course, in this case, the dosages are extremely low, and even a minor homogeneity leads to severe over or underdosings. This is something what we definitely cannot accept. And we have also redispersible phases, and these redispersible phases, that means these are products which you need to shake well before use because they are so unstable, they are sedimenting so fast. Like, for example, asthma sprays or something like this. These redispersible phases, they need an extreme good homogeneous mixture in the tank because they are so fast sedimenting. Even if it is an hydrofoil impeller, above the impeller, you have an horizontal rotation. Below the impeller, it's okay, yeah, vertical movement. But above the impeller, you have always horizontal rotation. And in that moment, when you have horizontal rotation, then you avoid an homogeneous distribution in the tank. You have different concentrations in the different levels of the tank, and this cannot be avoided at all. They define a complete suspension or full suspension when everything is moving. It has nothing to do with homogeneity. And since they are not able to reach homogeneity, they define an homogeneous suspension already according to the 90% criterion, which means 90% is, so to say, a mixture. The rest can be clear liquid, and they define this an homogeneous suspension. There's nothing homogeneous, absolutely nothing. If you need a really homogeneous suspension, then you need a different type of mixer. Then you need a vertical mixing principle. Vertical mixing means from bottom to top, everything which sediments at the bottom, which moves at the bottom, viscosities or densities which are different, they need to mix vertically up and recirculate it. Only in this case, you get an homogeneous distribution in the tank. As a result of this study, the conclusion is that you have in the lower volumes concentrations which are 10 times higher than the average concentration, 10 times higher, and at the top of the tank in the upper levels you have nearly no particles at all. So this is anything else, but this is not homogeneous, and this is not that what you can accept in pharmaceutical application, whatever pharmaceutical application that is. You need homogeneous mixing. The mixers which can do that are jet stream mixers. They are creating a stream directed on the bottom of the tank. They are recirculating the liquid in vertical rotation directions. You don't need any buffers because there is no horizontal rotation in the tank. No buffers mean easy to clean, absolute easy to clean, perfect to clean. And even if you have a cooling jacket, a heating jacket at the side, you have a better heat or temperature exchange with the wall of the tank because the liquid is moving from bottom to top. If you have only a horizontal rotation in the normal agitator, of course, then the hot area remains at the top and the cold area remains at the bottom and you have no heat exchange. Yeah, so that means in all the typical applications, mixing applications, jet stream mixers have a much better effect, homogeneity, cooling, if you have crystallization processes, etc., etc. My next topic is dispersion. Of course, you have also some very interesting key trends which require a controlled, not always a high shear dispersion, a controlled dispersion. The formulations are getting more and more complex. You have emulsions, suspensions, nanoparticles. And the problem is you must have a very precisely controlled process because when you go to the next process step, you have no chance to correct failures from the previous process step. So for that reason, it is absolute important that you have controlled dispersing conditions. And that is the reason for our machine designs. Today, we do not always need only small particle sizes. It's more important that we have narrow particle size distributions, and they must be homogeneously distributed in the tank with the jet stream mixers, but they have to be also very, very narrow, because the particle size is a critical quality attribute, CQA, critical quality attribute. So we have sometimes LNPs, liquid nanoparticles, and we make nano emulsions, and the critical requirement is an absolute uniform droplet size. So only this way you have a predictable pharmacokinetic development or use of your ingredients, and for that reason we need the best particle size distribution what you can get. One key trend today is we want to add the materials, powder materials, without opening the tank. Yes, we want to add it into a closed process system without opening the tank, because there are a couple of things. When we are adding powders from the top, then of course there is a risk when we have dust extraction systems or whatever that we lose material in an uncontrolled manner, and we can create dust, we can create critical atmosphere. All this can be avoided with our technology. We are inducting the powders directly into the liquid, typically also in a recirculation loop. 100% all the powder goes into the liquid, nothing goes in a dust extraction or in a filter or whatever. Absolute everything goes into the liquid, and we don't need to open the tank. This is not necessary. Another trend is you want to reduce the requirement of preservatives, or you don't want to use any preservatives. This can be reached when you have no contact with airborne germs. Airborne germs when you open the tank, or when you make an open powder handling. No, we can induct powder really from contained systems, enclosed systems with liquids, so without any contact with airborne germs, with anything, under controlled conditions, and that is an enormous advantage. Also, batch size independent, filling level independent, product independent. The process is always the same, controlled by the control system and completely independent from the operator. If one operator fills the powder in a little bit faster or a little bit slower, it doesn't matter, because we are inducting not the material in the speed what the operator fills it in. No, we are inducting it with our conditions, opening angle, induction speed, rotation speed. So independent from the operator, always the same quality. It creates a very strong vacuum. It can go down to 30 millibar absolute, and if required, even lower than that. And with this vacuum, we are inducting powder. Powder contains air. Every powder contains air. And the air between the powder particles is expandable. That means under pressure, you would compress it to smaller volume. Under vacuum, it expands. If we have a vacuum in the range of 30 millibar absolute, then the air expands 30 times of its original volume. What does it mean in a powder? The air is between the powder particles, and when the air is expanding 30 times in volume, then you see that here in the picture, the powder comes in as a dense stream and it gets more loose, and then you get huge distances between the particles. This is reality. That means the air expands so enormous that you are separating the particles before they get into the dispersing zone. This happens only in a fast-moving powder. Not in a vacuum tank, not at all. In a vacuum tank, when you fill in a powder amount, yes, and you have then vacuum, of course, the air goes also in all directions, but the powder particles are still touching each other. So this is a total different story, and this is a problem when you are mixing in a process tank with vacuum powder into a liquid, because you get them very compacted, the powders. So here it's the opposite.